In this video, we're going to take a look at the derivative of the natural log function and just make a few observations. So we'll get right to it. The derivative of the natural log function by definition is 1 over x. It's 1 over x. But students often don't see what's actually going on here behind the scenes. There's actually more that's going on than originally meets the eye. Just as a quick example, if you had the natural log of 5x plus 1, the derivative would not be 1 over 5x plus 1. We have to see what else is going on here. So this denominator here, the x, that is the inside. That's always going to be the inside of whatever your logarithmic function is. However, the numerator is not always 1. The reason this is 1 is because it's the derivative of the inside. So in general, if you have something other than x, then you'll need to take the derivative of that expression and put it in the numerator, and take the inside and put it in the denominator. So let's write that down real quick here. So in general, if you have the natural log of u, where u could be any expression of x, then the derivative would be u prime over u. And so that's the general log rule for derivatives. So let's try just one quick example. We'll have another video where we do lots more involved examples, but this is a good one just to get our feet wet. If your function is the natural log of 5x squared plus 10x minus 1, then the derivative will be a fraction. The denominator will be that inside there, 5x squared plus 10x minus 1, and the numerator will be this guy's derivative. So in this case, it'll be 10x plus 10, period. The 1 goes away. And so that's it. That's the log rule. That's how we differentiate logarithmic functions in general. Now we're going to close out this video just with a couple observations here about the derivative. If your original function is the natural log function, and I've graphed it over here, and remember it's only defined for positive x's, this graph's not defined for negative x's, and your derivative is 1 over x. Notice if your x is positive, then 1 over x, this will be positive. But what does it mean if a derivative is always positive? That means the original function is always increasing. That's interesting to notice, right? And because if you look at this graph over here, sure enough, it is increasing. It's increasing everywhere, in fact. All right, and second of all, if you look at the second derivative, the derivative of 1 over x would be negative 1x to the negative 2 if you rewrote this and used the power rule, which simplifies to negative 1 over x squared. If x is positive, and actually, matter of fact, even if it wasn't, negative 1 over x squared is always negative because you have a negative divided by a positive. But question, what does that mean if the second derivative is negative? Well, that means your original function it's got something to do with concavity, is concave down, right? Because if the second derivative is negative, that's the definition of concave down. Well, sure enough, look at that graph. It's concave down. So we hopefully now have a little bit of confidence that these actually are the correct derivatives of the log function. It helps us confirm everything that we already know about the log function, and so everything seems to fit real well together. In the next video, we're going to do some more difficult derivatives that require mixing and matching of the other rules we've already learned. But for this video, hopefully that just gets across the basic idea of the log rule.